So we're going to compare those exact same binary bits now to the binary bits of the PC. So let's go ahead and of the destination PC. So what is the binary representation of the destination? It's going to be 0, 0, 0, 0, 1, 0, 1, 0, 0, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. All right, so there we go. So that is the address of the destination. So address of destination. Perfect. So this is the network ID of source. So let's compare now these bits, just the bits of the network ID. When we look at these bits here and you come across, are they the exact same? Those bits of the network ID with the bits of the destination device? Yes. Do I care about these last bits here? No, I don't. I don't care about these bits here. Why? Because they're not part of my network ID. Only the first 24 bits are part of my network ID. So I'm comparing my network ID to the first 24 bits of the destination IP address. Do they match? If they match, we are in the same local area network. If they don't match, we're not in the same local area network. So they do match. We are in the same local area network. So what do I need to do now? Well, I need to find out what the MAC address is of the destination PC locally now. I can do that. Send out my ARP request. Send it out and say, hey, if you are 10112, give me your MAC address. And then I learn that MAC address, and then I can send the frame to the PC. But let's see what happens now if we're trying to reach a device that is outside of our local area network. So when we go to this example here, we're trying to talk to 192.168.3.2. And you can see that the PC says the destination host is not in my local network. Well, how did the PC know that? You see, and based on the fact that the PC is not in the local network, we are going to communicate with the default gateway. So I need the MAC address of the default gateway in this case. So I can send the frame to the default gateway, and then it can do what? It can take the packet and forward it on. But how did this occur? All right, so the PC, my local PC, is going to do what? It's going to figure out its network ID. All right, so right now, that is the IP address of my PC. What is my subnet mask? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I think I missed a number here somewhere. 5, 6, 7, 8. No, I didn't. 1, 2, 3, 4, 5, 6. 7. Wow, I just have way too many. There we go. And what happened up here? 1, 2, 3, 4, 5, 6. There we go. Can't count today. All right, so there we go. There's our subnet mask. So what is my network ID? My network ID is going to be, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. All right, so that is my network ID of PC, of my PC. All right, so there we go. So now what do we want to do? We want to take my network ID and compare it to the exact same binary bits in the destination address. So let's figure out what that destination address is. We have 192, so that should be 11, 1, 2, 3, 4, 5, 6. And then 168. Well, I'm going to need a 128 for that. So I need a 128. I do not need a 64. I need a 32, which brings me to 160. Don't need a 16. I need an 8. I don't need a 4. Don't need a 2. Don't need a 1. All right, so that's 168. And then we have 3, 1, 2, 3, 4, 5, 6, 7, 8. And then we have a 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's the IP address of the destination. So IP of destination PC. Now what we need to do is we need to compare. All right, we're going to compare. So I'm going to move all that down here. Now I'm going to move my network ID down here so we can see it a little better. Now let's compare. Let's compare the network ID of my PC to those same bits of the destination. Do they match? Do they equal each other? So does this match what's up above? Right above it? No, not even close. You can tell from the first binary bit they don't match. Right away. Mine is 0, theirs is 1. Done. We didn't even have to look any further than that. So right away, my PC knows not even close to being in my local area network. As a result of that, I need to talk to my default gateway. So the source of the packet is going to be 10.1.1.1. The destination is going to be 192.168.3.2. However, what's going to occur now is that the source of the frame is my PC, but the destination of the frame is the router. So I need to send an ARP request to get the MAC address of my router if I don't already know it in my ARP cache. Once the router responds to me with its MAC address, then I can complete the frame, send the frame to the router. The router then destroys the frame, looks at the packet, does its routing process, and sends the packet on its merry way. So really, it all comes down to the PC ultimately deciding in the beginning, is the destination within my local area network or is it not within my local area network? And this is why it's so important to understand IP addressing and subnetting and masks, because at some point in time in your career, you're going to end up in a troubleshooting scenario. And that troubleshooting scenario is going to test your limits on IP addressing and subnetting. Why? Because you might have two devices that aren't communicating with each other. And if you stare at their IP addresses and subnet masks, they appear to be configured correctly. However, they may not be. They may not be. What do I mean by that? Well, in order for these two devices to communicate with each other, not only do they have to have the same subnet mask, their IP addresses have to be in the correct subnet with that subnet mask. If they're not, then my computer's going to think the PC's in the subnet, when in actuality, the PC's not technically in the subnet, and therefore communication will not occur. The frames won't make it to the destination. Likewise, if a PC thinks that the destination is in the subnet, in the local area network, but it's not, then it's not going to ask its router to forward it. It's going to try and send it directly to the PC when it should be sending it to the router. So if you have your addressing wrong or you have your default gateway information wrong, then this is not going to work, because the PC is going to make a bad decision. It's going to think something's local when it's not, or it's going to think something's remote when it's not. So you have to get the addressing correct in order for this process to work. The process of communicating locally and the process of communicating remotely.